All right, so I had planned to talk about my own research, but then on March 9th, Scott Pruitt made some comments, and I rashly decided I wanted to talk about that. I'm sure you've heard about this comment. This is a picture of Scott Pruitt holding a miner's hat with his name on it, surrounded by coal miners. And his quote was, "I would not agree that CO2 is a primary contributor to the global warming that we see." And this was thoroughly covered in the media. And just to get it out of the way, it contradicts decades of research, contradicts the UN panel on climate change, contradicts NASA and NOAA scientists and EPA, and even the EPA scientists that he heads. Fact checkers called it false, says the science says it's wrong. It even contradicts some oil executives. But there was another part of his comment that got almost no coverage, and it said, "I think that measuring precision human activity on the climate is something very challenging to do." And the implication is, if it's challenging to do, then maybe we shouldn't do anything. And I want to make 3 comments about that. First thing I want to point out is you can say exactly the same thing about cigarette smoking. We know that cigarette smoking and lung cancer are connected, but we can't say with precision that if you smoke a cigarette, you're actually going to get cancer. And you can't say with precision when you'll get cancer or even if you'll die from that. But these are not arguments about why you should continue smoking. Later in the comment, you see there's tremendous disagreement about the degree of impact. You can say the same thing about cigarette smoking. You can find scientists who disagree. In fact, as it turns out, you can find the same scientists who challenge cigarette smoking and cancer connection as climate change. But back to this point, measuring with precision is very challenging to do. Yes, it is. But we've made these predictions for over a decade now, so we can go back to these actual predictions and see how well they did. And here's an example. This is from a forecast that was done in 1996. So all the data that came after 1996 is new, was not available to the climate modelers. So the dashed black line is showing the mean of all the model simulations, and the gray shading is showing the uncertainty, the standard deviation about that mean. So again, Scott Pruitt's right. We can't predict it with precision. That's the gray shading there. But we try to quantify that uncertainty. And the red curve is showing what the observations did. And you see the observations land right on top of the model simulations. So yes, it's challenging to do, but we can do it. But this is an example where we did it right. Sometimes we do it wrong. We are off. This is an example from Arctic sea ice starting from 1900 going out to 2100. The solid blue curve is showing the mean of the model predictions. And the shading is showing the extreme values of the model simulation. So the bottom part of that shading is the worst case of all the models. And you see that worst case actually predicts the disappearing of Arctic sea ice by 2100. But look at the observations. The observations end up going outside the range of even the worst case model. So Scott Pruitt's right. It is very challenging. Sometimes we're wrong in the dangerous direction. So that leads me to my final point, which is that the challenge of measuring precision is a reason to be cautious, not a reason to do nothing. Thanks.